Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was explaining the first chapter of 9th standard mathematics, that was on number systems. So in my previous video, I was explaining examples which were there before exercise 1.3. So in this particular video, we will start discussing exercise 1.3 of this number systems. So in this exercise 1.3, coming to the first question, here there are few set of questions in first question. You have to take the value of those particular numbers. Means here in the first question you have 36 by 100. So you should calculate the value for that and you should say what kind of decimal form that particular number has. So first you can take 36 by 100. So when you do 36 by 100, you will get 0.36. So here, what kind of decimals you are getting? Here you are getting a terminating decimal form. So here you are getting terminating decimal form. So that means after a particular number, it is terminating. So here this is terminating decimal form. This is first question. So coming to the, so this is first question in first question. So coming to the second question in the same first question, here they have given 1 by 11. So when you calculate the value for 1 by 11, it is 0.090909. It is going on like this. So that means here 09 is repeating. So this is not terminating decimal form. This is non-terminating decimal form. So this is non-terminating decimal form, but values are repeating. So here 09 is repeating. So that means after a point, values are repeating. So that means non-terminating decimal form with repeating pattern. So you can call repeating pattern. So now coming to the fourth question, third question you can do on your own. So coming to the fourth question, here you have 3 by 13. So when you calculate the value for this particular 3 by 13, you will be getting 0.230769 and again you will get 230,769. Again you will go on getting 230,769. So that means here 0.230769 is recurring. So that means this is also non-terminating. So this is also non-terminating decimal form and this is having repeating pattern. So like this remaining questions also you can try out. You can just find out the value of those rational numbers which they have given and just see whether it is terminating or non-terminating. Coming to the second question, here you have 1 by 7 is equal to 0.142857 and this particular number recurs again like 142857, 142857. So now based on this, without doing any long division, you have to find the value for 2 by 7, you have to find the value for 3 by 7, 4 by 7, 5 by 7 and 6 by 7. So now in order to do 2 by 7, the simplest method is you can just multiply 2 with 1 by 7. Because when you multiply 2 with 1 by 7, you will get 2 by 7 because 2 means it is nothing but 2 by 1. So when there is multiplication, directly you can multiply numerator and numerator, denominator and denominator. So 2 ones are 2, 7 ones are 7. So again 2 by 7 you will get. So that means 2 by 7 I can write as 2 into 1 by 7. So what is the value for 1 by 7? 2 into 0.142857. So you got this particular value. So when you multiply 2 with this, you will get 0.285714. That's it. Similarly, if you can do this for 3 by 7 as well. So 3 by 7 also you can write as 3 by 1 into 1 by 7. So that means 3 into 0.142857 is there. So when you multiply 3 with this, you will get answer as 0.428571. So again this particular value recurs. So in the previous case also, when you do 2 by 7, so this particular 0.285714 also recurs. So similarly when you do 4 by 7, so 4 by 7 is equal to, again you can take this as 4 by 1 into 1 by 7. So that is nothing but 4 into 0.142857. This is a recurring number. 0.571428, which is a recurring number. So without doing division, you can straight away do like this and get the values for 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. So 5 by 7 and 6 by 7 you can do on your own. Coming to the third question, here they have given certain numbers, decimal numbers. So those numbers you have to express in P by Q form. So coming to the first question in third question, here they have given 0.6 where 6 is recurring number. So similarly, how I did example 6 and example 7 and also example 8 in the previous video. So same method you can use here to express this in P by Q form. So you can refer my previous video also. So here 0.6 and this particular 6 is recurring, so that means you can take this as x is equal to 0.666 and it goes on like this. So I'm considering this number 0.6, the 6 which is recurring, as x. So that is x is equal to 0.66666 and it goes on like that. So here you can see only one number is recurring after a certain point. So that means here I have to multiply this value with 1 followed by 1 0. So that is 10. So when you multiply 10 on both sides, you will get 10x. So this is BS. BS means both sides. So 10x is equal to 6.666 and it goes on like this. So 10x is equal to this, you can write as 6 plus 0.666. It goes on like this. So here this value you can take as x. So it will be 6 plus x. So 10x is equal to 6 plus x. So 10x, when you bring that particular x to LHS, it becomes minus x, which is equal to 6. So 10x minus x is equal to 9x, which is equal to 6. So x is equal to 6 by 9. So 6 by 9, I can write this as 2 by 3. So here you can see 2 is an integer, 3 is an integer, and denominator is not equal to 0. So that means this is a rational number. So rational number. So like this you have to express a particular number which is given in rational number. Similarly, coming to the second question, in the third question, here they have given 0.47. Here only 7 is recurring, not 4. Only 7 is recurring. So only one number is recurring after a point. So that's why here also you can multiply this with 10. So I will take x as 0.477777. It goes like this. So now I'll multiply 10 on both sides. So that will be 10x is equal to, when you multiply 0.4777 with 10, it will become 4.777, like this. Now you can just subtract x with this particular 4.777. So now if you subtract 4.777, it goes on like this with x, that is 0.477777. So here all these values will become 0. 7 minus 4 is equal to 3. Here 4 minus 0 is 4. So that means here straight away you can take 4.3 plus 0.477777, because I have subtracted 0.47777 with this 4.777. So that means I have to add 0.4777 to 4.3. So now you have this particular x value. So this is also recurring. So this x value you can take. So 4.3 plus x will be there. So 10x is equal to 4.3 plus x. So we have got 10x is equal to 4.3 plus x. So this x you can bring to LHS. It will become 10x minus x is equal to 4.3. So 10x minus x is 9x, which is equal to 4.3. So x is equal to 4.3 divided by 9. So you can multiply 10 to both numerator and denominator. So this 4.3 becomes 43 and 9 becomes 90. So here also you can see 43 is an integer, 90 is an integer. So this is a, and also denominator is not equal to 0. So this is a rational number. So in the same third question, there is third question which is 0.001 and 001 is recurring. So here you should multiply with 1000 because three numbers are recurring after decimal point. So you have to multiply this with 1000, that is 1 followed by 3 zeros. So that means 1000x is equal to 1000 into 0.001001. So this value you can multiply with 1000. So like that you can do similarly. So now we will move on to the fourth question. Here they have given 0.999 and it goes on like this. So this you have to express in P by Q form, that is as a rational number. So now you can consider this as x, so that is 0.999 and it goes on like this. So 10x is there. So when you multiply 10 on both sides, you will get 10x into 9.999 and it goes on like this. So 9 plus 0.9999 goes on like this. So here you can consider this as x, so 9 plus x, so 10x is equal to 9 plus x. So now you have got 10x is equal to 9 plus x. It will be 10x minus x is equal to 9. So 10x minus x is 9x, which is equal to 9. So x is equal to 9 by 9, which is equal to 1. And 1 can be expressed as 1 by 1, which is a rational number. So here you might be surprised that we are getting a whole number, that is 1. Why? Because here when you take 0.99999 infinite times, then it will be equal to almost the value 1. So that means if you have infinite nines after decimal point, so that is nothing but it is tending towards 1, and mathematically it makes sense as well. Coming to the fifth question, here you have to get the value for 1 by 17 by doing division. So always remember, when we did 1 by 7, we got 0.142857 as answer. So that means this particular value was recurring. So that means 6 digits were recurring. So in 1 by 17 case, 16 digits will be recurring after decimal point. So if you want to check that, then you have to do the division of this particular 1 by 17. So you can do that on your own. Coming to the sixth question, here whenever you take a P by Q form, if this P by Q form should have a terminating decimal, so if this P by Q should have terminating decimal, then what should be the condition for Q? This Q, when you factorize it, so when this Q undergoes factorization, either it should come to 2 or 5 or powers of 2 or 5, powers of 2 or 5 or both. Because let's say if you take 2 and 5 in the denominator, any number, for example if you take 3 in the numerator and if you take 2 in the denominator, then you'll get the answer as 1.5. So here you can see you have a terminating decimal. So terminating decimal means there is no number after a certain number. So that means after 5 there is no number. Similarly, if I have 3 by 5, then 3 by 5 is equal to 0.6. So here also decimal is terminating. So that means either power of 2 or power of 5 or both should be there in the denominator as Q in order to get terminating decimal. But if you take any other prime factors like 7, or if you take 11, or if you take 3, then whenever you do 2 by 7 or 3 by 11 or 4 by 3 or anything like this, if there is 3, 11, 7 and all coming in the denominator, then you will not get a terminating decimal, you will get a recurring decimal. So that means you will get a recurring numbers after decimal point. So if you want to get terminating decimal form, that is if it has to end after a particular point after decimal point, then either 2 or 5 or powers of 2 and 5 or both should be there in the denominator. So at that time when you take the value of that particular P by Q, you will get a terminating decimal value. Coming to the seventh question, here you have to write three numbers whose decimal expansion has no recurring numbers and it should not terminate as well. So in that case, you can just randomly go on writing the numbers. So for example, one number I'll write as 0.2163564021302013, and it goes on like this. After that, I'll put some dots after this particular 3. So these dots indicate that this is non-terminating decimal value, and here there is no repetition of a certain set of numbers. So that means here it is not recurring, and also here it is not terminating. So similarly, you can write two more also. So 0.101001000001000001000000. Here you can clearly see there is a pattern, but there is no repetition. Here you are not getting a terminating number, and also here you are not getting any recurring number after a point. So that's why this is also non-recurring and non-terminating. Similarly, one more example also you can write 0.43678913, and it goes on like this. So here also it is not recurring and it is also not terminating. So like this you can give so many thousands of examples for this particular 7th question. So coming to the 8th question in this particular exercise, here they are asking find 3 different irrational numbers between rational numbers 5 by 7 and 9 by 11. So here they have given 2 rational numbers, that is 5 by 7 and 9 by 11. So you have to find out 3 different irrational numbers between 5 by 7 and 9 by 11. When you take the value for 5 by 7, that is equal to 0.714285, and this particular value is recurring. And when you take the value for 9 by 11, it is 0.818181, so that is nothing but 0.81. Here 81 is recurring. So now you have 714,285, and you have another value that is 0.81. So these numbers are recurring here, and these two numbers are recurring in this 0.81. So here you have to find in between numbers. So that means either it should be greater than this value and less than this value. So in order to get greater than this value, simply you just increase this particular second number. So that is 0.72, and then you go on putting some random numbers. So I'll put 3, 6, 7, 8, 5 like this. So 7, 2, 3, 6, 7, 8, 5, 6, 5, 4, 3, 9, and it goes on like this. So like this you can see here 0.72, if it is starting, then it is obviously greater than 0.71, and it is obviously less than 0.81, because here it is 0.8, here it is still 0.7. So that means it is less than 0.81, but here it is 0.72, here it is 0.71, hence it is greater than 0.71. And I have put some random numbers after 0.72 in order to make it an irrational number, because here we should not give any rational numbers, we have to give irrational numbers between these two numbers. So similarly you can take one more 0.73657891, and it can go like this randomly, and I can give one more number 0.74568710, and here it is again 9, 8, and it goes on like this. So here randomly you can go on giving numbers, but always remember it should be greater than 0.71 and less than 0.81. So in order to do that, I have taken 0.72, 73, 74 in the start, and then I have put some random numbers in order to make these numbers irrational. So I have given 3 irrational numbers. You can find much more irrational numbers between this 5 by 7 and 9 by 11. Coming to the 9th question, here you have to find whether the given numbers are rational or irrational numbers. So coming to the first question in this 9th question, here you have root 23. So when you take root 23, it is equal to 4.79583152, and it goes on like this. So here you can see there is no repetition of a particular set of numbers, and there is no termination also. So that's why this particular root 23 is irrational number. So coming to the second question in this 9th question, here you have root 225. So when you do root 225, you will get 15 as your answer. So that means this particular number is a rational number. So now coming to the third question in this particular 9th question, here you have 0.3796. So there is no recurring numbers after decimal point, but this particular decimal is a terminating decimal form. So that means it is terminating after a value, there is no continuation. So that means this can be rational number, because if I multiply this with 10,000, then this becomes, if I multiply the numerator and denominator with 10,000, this becomes 3796 divided by 10,000. So that means this can be expressed in rational number form. So that's why this number is a rational number, because it is terminating after a particular value. Now coming to the fourth question, here you have 7.478478. So here you can clearly see 478, 478, it is repeating. So that means here this is not terminating, but here recurring pattern is there. So that's why this can also be a rational number. So now coming to the fifth question in this particular ninth question, here you have 1.101001000100001, and it goes on like this. So here also you can see there is no recurring pattern and there is no termination as. So this is all there in this particular video. I have taught the exercise 1.3 in this particular video. The next concepts which are there in this particular number systems chapter, I'll be discussing in my next videos. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.